Hey, all you penny pinchers. We're going to talk today about improper integrals. So what's an improper integral? Well, an improper integral is going to be one that looks like this. We'll say it's 2, we'll look at this one here shortly, 2 to infinity of 1 over x dx. Okay? And how we're going to do this is we're going to look at, because we can't evaluate infinity, but we're going to let t go to infinity, and we're going to calculate this integral from 2 to t of 1 over x dx. Okay? And so what we're going to see is we're going to evaluate this limit right here, and then we're going to take the limit as t approaches infinity. So you guys know what this is. This is the natural log of the absolute value of x. We're going to evaluate from 2 to t. I forgot something here. We're going to plug in the limit as t approaches infinity. And so this is going to equal the natural log. Let me write the limit here. The limit as t approaches infinity of the natural log of t, which we're going to say has to be bigger than 2, so it's going to be positive, minus the natural log of 2. Well, what happens when we plug in infinity here? We're not really going to plug it in, but what happens when t gets big? Well, that goes to infinity. Okay, and so when that happens, that area is so big we can't count it. We say that this integral. Let's change this for us. This integral diverges. Okay, so that's the word that we're going to use there. We say it diverges. Let's put it in a nice color of yellow. There you go. Highlighted it for you. It diverges. All right, so let's see. If we look at the graph here, okay, and we integrate from 2 to, we can't do that, sorry. I was trying to put so if we integrate from 2 here all the way out this way, you can see that it gets smaller and smaller and smaller, but there's infinitely many values there. It gets so big that we can't count it. Okay, let's look at another example. So here we have an example, 1 over x squared. It's real similar to the one that we just did. And so hopefully you guys know what we're going to do with this. We're going to make this the limit as t, we'll say, goes to negative infinity. And we're going to integrate from t to negative 4. Let's make this x to the negative 2nd dx. Well, now this is, we've still got the limit as t, we'll make that a t, goes to negative infinity. And this is negative x to the negative 1. We're going to evaluate from t to negative 4. So when we plug that in, so this is the limit as t approaches negative infinity of 1/4 minus, I bet it becomes plus 1 over t. Now, as we apply t goes to infinity, this goes to 0, and so we would say that integral equals 1/4. So that area of this right here equals 1/4. All right, so let's take a look at this on Desmos and see what happens. So as you can see here, I've plugged in 1 over x squared. I've moved it to the left a little bit so we can kind of see. You can see this gets smaller and smaller, and then it gets closer to 0. But notice what I've done here is I've plugged in 1. Well, 1 is over here. All right, let me graph x equals 1. So x equals 1, and x equals negative 4. All right, I'm going to put those both in green. But notice what happens if I were to calculate this area. I have this asymptote here So that area would become infinite, and it can't work when I cross zero, when I cross an asymptote. But what happens then when I start to move this to the left? You'll notice that zero, it's still undefined. But as I go further down here, negative 2,000, negative 4,000, as my numbers get bigger, you start to see that this is getting closer to 0.25. And we're getting closer and closer and closer to 0.25. And if you remember, let me go back, we said our integral was 1/4, all right? It was 1/4, which is approximately 0.25. And as I keep going, that value is getting closer and closer to 0.25. Okay, now at some point Desmos just gives up and says these numbers are too big, I can't do it. But so far, I mean, at negative 200,000, negative 300,000, it works. And you can see they're getting closer and closer and closer to that 0.25 value. All right, so hopefully that makes sense to you. Um, we will do a lot more of these in class. Oh, I forgot something important here. So we will say this, okay, so we will say that this integral, okay, this integral converges. All right, so that's what we're going to say. It converges to the value. We're going to put this in a lovely color of yellow again. It converges, and where does it converge? It converges to the value of 1/4. And so that's what we mean by improper integrals. We have this infinity here, or maybe infinity up top here, and we're going to look at a lot of those. When does it converge, or when does it diverge? All right, guys, thanks for watching. I appreciate you doing so. Hopefully this kind of makes sense. We'll talk about it in class some more. We'll do a lot of examples, and this is where I think Calc 2 really starts to get a little wonky, if you will. Hey, thanks for watching. We'll see you in class.